Okay, I want to see how good ChatGPT really is, and I want to see if it can help us add a local auth strategy to a Nestjs application. All right, so in order to play with ChatGPT and a Nestjs local auth setup, I've actually done a bit of pre-work. So if you go out to nestjs.com, you go to documentation, they've got some really good intro, some setup stuff here. I've basically run through all of this and got a new project. Additionally, if you go down to security, they've got a great section on authentication, authorization. So really, I've gone through all of this as well and set up all the basic passport authentication stuff that they have you do. We've added the users module, all this stuff, all the way up until you get here. And one of the things that the documentation, this little tutorial falls short is that it has you, let's see, where'd it go? Already passed it, you know what? It has you hard code your users. So these are right in code in your user service.ts. We're gonna move those users into a real database. And so the password cannot be plain text. That's what we're gonna use the password hashing for. And if you keep scrolling down, passport local, man, it's way down here. Okay, jot functionality. We're going to sort of stop here. So I'm not going to get into using the JWTs, doing all that. We're going to keep it pretty simple. We're just going to take everything that the tutorial's done up to here, and we're just going to try to make it real. A couple other notes, and then we'll jump into it. In my setup here, so like I said, I've run through some of the Nestjs docs for authorization, authentication, and set up that. In this project that we're using, I'm actually using Turbo Repo to set all this up already. So we're going to try to ignore that. The file structure might get a little confusing on the side, but under apps, under users API, that's where we're going to focus basically all of our time. We're also going to use Postgres for our database. I've already talked about Nestjs several times. We're going to use Prisma. We're going to use Docker. So a lot of technologies here. We're going to sort of skip over those as much as we can. I'm going to try not to get sidetracked and just talk about the local auth strategy in the database. All right, so let's go to the terminal. I've got a bunch of different terminals here. I like to try to keep things segregated. So in our root directory, that's what Turbo Run is. We're just in our root directory of the entire Turbo mono repo. Oh, and we're using pnpm. We're going to go ahead and just run pnpm run dev. And this is going to start all of our different dev servers here. Again, the only one that we care about is this users API dev that it's going to kick up. And to make sure this works, we're going to hop over to Postman. That looks like good startup logs there. And we're going to just make sure that we can get users, that some basic authentication is set up with an error when I put in the wrong username or password. And then if I, log in correctly, I should get a response back. So if I get all users, okay, this seems to work. It's giving us status code 200. If I log in with an incorrect john@attackers.com, boom, I get unauthorized. And if I log in correctly with the user under auth login, I get this. So again, if you've done, if you know something about Nestjs and you've done the basic setup, this should all work for you out of the box. Set up out of the box, what they had us do under users API, this is where my Nestjs application is. Let's see, they've got this auth here. So we do have an auth service, which is going to try to validate the user. And when we go into the user service here, everything is hard-coded, like we've talked about. And this is not what we want. So let's set up a database and move these users into that database. This is going to take a couple of steps, but we're going to get there. We're here in our root directory, and we're going to go ahead and touch a Docker compose YAML file. We'll then open that and paste in just some basic standard Postgres stuff. Okay, so we call it DB, we call it Postgres, we put in a Postgres password. By default, the username is going to be Postgres, and also by default, if you don't specify a database name, it will be the name of the default user, so it will also be Postgres. And one thing we want to do is validate that everything is working, and we can do that with this other nice little Docker image called add-miner, and we'll see how that works. So if we stay here on the CLI and we just say docker compose up, if you have not done this before, it's going to have to download these images. I've already done it, so everything is right where I want it. And as you can see, add-miner kicks up right away, and it's got running its local development server on 8080. So if I go there and I trust it, it's going to show me this little UI here, which is nice. So I can say, let's go to Postgres. Server DB is what it's going to be looking for here in your Docker YAML file. This routes you to that service domain. So the username, like I said, was Postgres. The password is example. I don't know if I did that right. And the default database is also Postgres, right? So if I log in, hey, there we go. Okay, so the database works. There's nothing in here, obviously. So now we're going to use Prisma because Prisma is freaking awesome. And we're going to go ahead and set up a schema for our database. And I'm going to do all of this within my, again, sorry for the monorepo, within the user's API service here. So in here, we're going to have to install Prisma. And again, I'm using pnpm, but otherwise you would just say npm install. We're going to do Prisma. We're also going to do the Prisma client. We're going to do that as a dev dependency though. You don't always have to install the @Prisma client, but I'll tell you what, I've been running into some issues with pnpm, Prisma, and npm working well together. So there's going to be a few times when we use npm instead of pnpm. And as far as I can tell, that's some weird artifact with how Prisma is setting up all of its links and everything else. All right, so now Prisma is installed. We're going to go ahead and init Prisma. So we're going to say npx prisma init. And what this is going to do is it's going to create a default Prisma schema file for us. And it's also going to create a .env file since we don't already have one in our project. And they've got some nice directions here, right? Next steps, set the database URL. Okay, we'll do that. Let's go ahead and just follow exactly what they're saying right now. So they created this .env and it's got all this basic stuff in it. And we're going to go ahead and update the username to Postgres, just like we just logged into that UI. The password was example. Localhost is fine because in this case, we're connecting from our host machine. We're not connecting inside of the Docker environment. If we were, that would be DB. We'll leave this as localhost for now. The default database is going to be Postgres, schema public. That's a fine default. And right now, before I forget, I'm going to go ignore this .env file from gitignore so that it does not get checked in. Okay, so we got that set up. Step 2, set the provider in the data source and schema Prisma. So you'll notice that Prisma generated this folder and it generated this file schema.prisma. And it defaults, I think, to Postgres. I'm not sure. Maybe it detected I had Postgres. But this is what we want. We want the provider as Postgres, database URL mapped to what we had in that .env. So this is looking solid so far. There's really nothing to change here. Run Prisma DB poll to turn your database schema into a Prisma schema. So if we had an existing schema, an existing database, we could run Prisma DB poll and it would actually introspect that database and generate a schema file for us, which is pretty sweet. In our case, we're not going to do that. We're actually starting from scratch. So we're going to skip that step. We're also going to skip the generate step for now until we get something in our database, some kind of table setup. So we're going to grab, I've got a really simple user model here, and it's actually based on exactly what we see in our user service. We had a user ID, a username, password. So in the Prisma schema file, we're going to say model user, which basically says what table it is. And then I just mark out the same things here, user ID, password, username. I do want username to be unique, and the user ID is obviously the ID, the primary index of the table. And by default, it will auto increment, so I don't have to set it each time. So now that this is set up, we can come back to our terminal here. And I want to say, take this Prisma file and go ahead and create our database and update the tables. So to do that, I can say Prisma DB push. And while this is running, I'm going to go ahead and hop over to our add-miner here. And if I just hit refresh, there we go. We see that in this Postgres database, there is a user table. I can select data on it. I can just view the table, and it's got my columns and types in there: user ID, password, username. Solid. Now, the next thing you want to do, anytime you've changed your database schema, Prisma gives you this Prisma client where it makes working, it's like the ORM to that database layer super easy. So every time that you change your database schema, update your Prisma file, do a DB push or whatever, you want to make sure to always say npx Prisma generate. So you'll want to do npx Prisma generate. That will generate the client at this special node modules subdirectory. And then they give you this nice little code snippet here to actually pull in that client to your code and start interacting with your database with it. And we're going to use that to seed our database. So in order to do that, we're going to create a new file here, and we're just going to call it seed.ts. Let's go ahead and import this before I forget. We're going to have some kind of main function here that will get called. So async function main, doesn't really matter, but I am going to say when main finishes, I want to make sure to catch any errors. And in fact, what I'm going to do is say .then first. And if it succeeds, then I just want to say prisma.disconnect. And if it throws an error, obviously, I'm going to say console log the error, and then also prisma.disconnect. Just try to make sure everything shuts down somewhat clean. Now, the cool thing is, since I generated this Prisma client from my schema, when I'm inside of this main function where I'm going to seed my database with a couple of users, I can say Prisma dot, and they've got all the standard attributes and methods on here, but then I also have a user attribute, and this is my user model. I can count, create, do all my normal CRUD operations and everything else. It's really fantastic. So I'll go ahead and create many, because I want to create my users that are hard-coded right now. So to do that, we're going to say data. And data is actually, I'm going to do this as an array. And within each of these, it knows that I need a username, password, and user ID is optional. So actually what I'm going to do is try to keep this easy on myself. I'm going to just copy this data here. So we're going to grab this, come back to seed, paste this all, and just get rid of the user IDs and clean up all these extra parentheses everywhere. Boom. So it looks like that. And that's what's going to seed our data. And I'll go ahead and put an await in front of this just to make sure that that all works the way that I want it to. So this is looking good, but now we need a way to call this file. And the way we're going to do that is we're going to go back to our package.json, and we're going to make sure we go to the right package.json here. And we're going to add in a special script just for Prisma. All right, so this is going to look like this. So you say Prisma seed, you're adding a command, and it's just going to call TS node. It's not going to do all the type checking. It's just going to transpile and run it. And we're going to call Prisma seed.ts. So then the way that we can call this is we can say npx Prisma, like we did before, db seed, and it will call through to this script. And we'll see if this works. I might need to install a dependency or two to get this working the way I want. Hey, look at that. Looks like it worked. So now if we go back to our add miner, I'm just going to hit refresh here. I'm going to go to select, and there we have it. We have a couple of users here. As we can see, the password is still in plain text. We need to fix that. So here comes ChatGPT to the rescue, because what I want to do in this seed file is I don't want the passwords. I want something hashed. So let's go back to our root project real quick. We got Docker running there. We'll just go ahead and use this one. And there is this really cool little tool called GPT CLI 3 or GPT-3 CLI. So if I go to npmjs.com and I say GPT-3, actually, honestly, if I just say GPT CLI, there's a whole bunch. OpenNode CLI, OpenAPI Node CLI, Assistant CLI, all this stuff. The one that I've started using, and they're all 9 days old, 16 days old, right? One of these is going to win the race. I don't really care which one. I like this particular one because it's extremely simple. All you do is download it, you give it your auth key, and then you're off to the races with your ChatGPT. And another reason that you actually probably want to do this is that if you just go to ChatGPT OpenAI, a lot of times I come here and it says, oh, sorry, we're busy. We're not going to be able to fulfill that request for you. But if you sign up with OpenAI, I always want to say Open API. If you sign up with OpenAI, you get your own API key, and they only limit you, whatever it is, 20 requests per minute or something like that. Pretty reasonable for our application, our use case here. So I'm going to go ahead and just kind of copy this. You guys can follow along, do the same back there at home. Wow, lots of things deprecated. Yeah, it's still, PNPM is still complaining a lot at missing peer dependencies and whatnot. It doesn't really matter. All right, so then we're going to say pnpx GPT auth. And what this is going to do, oh, you know what? Okay, it doesn't like this. I need to go back to using npx GPT auth. Like I said, a lot of times PNPM doesn't really, maybe I have a bad setup on my machine or something. So you're going to probably want to say yes to this. And it's going to kick you over here and set up a new secret key. I'll go ahead and do one so you guys can watch. And of course, I'll hopefully remember to trash it when I'm done. Paste that right in there, enter your API key, boom. And now if I just say something like npx GPT, hello GPT, how are you? Of course, if you use like question marks and stuff, you got to make sure to put it in quotes. There we go. I'm doing great. Thank you for asking. How can I help you today? I have a challenge for you. So let's go ahead and just see what ChatGPT gives us. npx GPT, how do I hash a password in JavaScript? Let's see what it's going to give me here. To hash a password in JavaScript, you can use the Crypto.js library. It's got all these algorithms. It's got some sample code here. Pretty cool, I guess. Let's see, hash a password, etc., etc. Now, one thing that's interesting is when I actually did this over Google, everybody says, use bcrypt. So, GPT, why should I use, what is this? The Node.js crypto library over something like bcrypt to hash passwords? One thing that you're going to find is that the more specific you can be, the more you can feed ChatGPT, the better a response it's going to give you. Node.js crypto library offers a wide range of algorithms that can be used, blah, 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 blah. It's easy to implement. Also provides secure, reliable passwords, allowing you to keep. Bcrypt is a good option for password hashing, but is not widely supported as Node.js crypto library. Okay, well, what if GPT is just telling me what I want to hear? Why should I use bcrypt instead of the Node.js crypto library? A little bit of confirmation bias, y'all. Here it comes. Bcrypt is a more secure option than Node.js crypto library because it is specifically designed to be resilient to brute force attacks, etc. Here's my thing about ChatGPT. It is a wonderful invention. It is a mark of our technological advancements. Before AI was bleeding edge, right? It was on the edge of invention and risk takers, but now AI has been commoditized. It's something that's accessible to everyone, but it's not going to replace anything. It's a tool that we add to our belt, but you can't just use it mindlessly. You have to think about what you're doing. You have to realize its limitations. You have to realize that if you ask the question just the right way, you're going to get the response that you're looking for. And so while we're going to add it to our belt and we're going to use it a lot more as a tech industry and as a people, we have to realize its limitations. We have to realize that it's just one input that needs to be assessed, and you need to apply the human experience, the human wisdom on top of the machine to know what the right thing to do is. In this case, it didn't even tell me about bcrypt, which I know that I want to use. And so I'm going to get more specific, and I'm going to say, how do I hash a password using bcrypt? And we'll use some of its code to inspire us. We're not going to copy paste, right? Just like Stack Overflow. All right, cool. This is looking a little bit better. So let me go ahead and install bcrypt. npm install bcrypt. While that's running, we'll go back to this one here. Okay, it's just using the hash. It's just giving whatever this is, a salt, I think, of 10 cycles for the password. And then it's got this little thing about compare a password. So we'll talk about that maybe later. So bcrypt is here. So all I want to do here is I'm going to go ahead and import bcrypt. And actually I forgot, but I need to install the types bcrypt as well. We'll get that going. And there should be this hashing function that's going to come out of this. So then I'm going to say John's password is await hash. Oops. And it's going to be the password, which is change me, in quotes, of course. And the salt or round, which I'm just going to go ahead and say 10 here. So we'll do that one, and then we'll do one for Maria, which is guess. And we'll go ahead and replace these with John password. Oops, I didn't do the right password for Maria here. Maria password. And now that we've updated the passwords, let's see if we can npx prisma db seed and go ahead and put the hashed passwords into the database. If we go back to our add miner here, where did add miner go? We'll go ahead and close this down. Oh, it failed. Let's see. Oh yeah, it failed because username is supposed to be unique. And when we seed, we're just running that seed script again. And so it's running into a unique error where I'm trying to insert John and Maria again. So at this point, we're going to use Prisma a little bit more to our development environment advantage. So one thing I want to do is, now that we have a basic schema here, I want to tell Prisma this is the first schema. I want to do my first migration for this. So Prisma migrate dev. When I do this, all it's going to do is basically do like the drop and create table stuff with my basic schema here. We need to reset the public schema at localhost. Do you want it to continue? Data might be lost. Yes, because I'm just going to reseed this anyways. Name of migration, we can say init. And as you can see, Prisma is cool here because what it's actually doing is it knows that I had a seed command. And so it's running that seed command. So if I go back to add miner now and refresh, everything works great. Now, if my database ever does get out of sync again, where I need to refresh and reseed all the data after I've been mucking with it, I can actually say Prisma migrate reset. And this will drop my tables, recreate my tables, rerun my seed scripts. Yes, you can delete everything. Awesome. Everything's looking good. So with the database taken care of, we're going to switch now to updating the code, because we've done all this database we've done all these database updates, but this is still using these hard-coded values. So the first thing we're going to do, let's close out all this stuff. We don't really need that anymore, I think. Don't even really need the auth service or my notes. We want the user service, and we do need the auth service, my bad. So we'll keep that open just for a second. And here we're going to pull in the Prisma client the same way we did in the seed script. So we had these. So we're going to go ahead and pop these to the top. Get rid of the hash because I don't need that right now. So I pull in the Prisma client. create a new client. Go ahead and close that for now. And we're going to go ahead and replace this find all and the find one. And then we'll check those in Postman and make sure they're working properly. So I'll say prisma.user.findMany, I guess. And I don't think I need any arguments there really. I'm just going to say const users equals, wait, we'll do that. And then instead of this .users.map, we're just going to say users.map because we still want to remove the password. We don't want to return that to the caller. In fact, let me just remove this. And we're going to do something very similar here, right? It's going to look a little different. So we're going to say Prisma user find, what is it, unique? Because we're trying to find it where the username matches. So we're going to say find unique and where, these TypeScript helpers are so awesome, username is username. We'll return, we'll save, and this basically is swapped out for the database. So if we go back to our get users, which is a public endpoint, should just return everybody. Seems like that's working. If I say user login, that should still error. Now this login, okay, this login no longer works. This is a good sign. Let's see why that is. So back in our auth service, this is doing users find one. We get the username and it's trying to do this password comparison that we did before, but now we've hashed those passwords. So just so we know that this is all working, we're going to go ahead and use the Nestjs logger here. I'm just going to log out the user info, and I'm also going to log out logger.log the username and password that are getting passed in here. So let's do that one more time. Make sure we know what's going on. Yep. Okay, we're getting the user out of the database. Good. And we're just doing a bad comparison here. Now, what we might be tempted to do is we might think, oh, well, since we hashed the password this way, we're going to do this again. We're going to calculate another hash for the password coming in, something like this, for the password, and compare those. This, unfortunately, does not work. Every time you hash something, it could come out a little bit different. But bcrypt provides this utility to compare. Let's see if GPT knows how to show us that. So let's go back to GPT. Where was I running ChatGPT? Here, I don't know. And if I say npx GPT, how do I, or let's do this, give me a code snippet to validate a password using ChatGPT, or sorry, using bcrypt and JavaScript. So if I get really specific and I kind of know what I'm looking for, it's probably going to give me exactly what I want. Do check password. Yep. So it's using this compare function, which is absolutely correct. So instead of doing this, I'm just going to remove all this logic. All I'm going to say is I'm going to pull in compare from bcrypt, and I'm going to say compare the, which one is coming in? This is the one that's coming in. So the raw password that's getting passed in to the user.password that is already in the database. Let's make sure that refreshes. And now if I log in, boom, it's working. And if we go back to the console output here, we can see that everything's working the way we want. One thing you'll notice though is that we're logging out the password because that comes back on this default user service find one. This is not good. So what I would actually recommend here is that in your user service, that you actually have a specific function here that says async, get password of a username. And that way, you know that you're exactly explicitly asking for this sensitive data. And then the second thing you can do is when you do find one or find all, you do something like this. There's better TypeScript friendly ways to do it, but you basically make sure that you're always pulling out the password of any other thing. It's like any sensitive data is always stripped out. You know, you would implement a utility function to do this unless you're explicitly asking for it. Well, I hope you guys enjoyed going through some of that. You know, like I said, I mean, ChatGPT, it's amazing, but just think of it as a tool that you can add to your tool belt. It's not going to replace anything. It still needs human wisdom on top of it, and you still got to be suspicious of it. I think the thing for me is that ChatGPT is kind of like it's like an internet summarizer. You know, it's going to go out there, it's going to give you kind of the short soundbitey answer to things. But if you really want to go deep into a subject, you're going to have to still go read deeper materials, read white papers, even the Stack Overflow. You know, you get really deep into somebody's very specific problem with ESLint and TypeScript and PNPM. And those are the things where you're going to find much deeper levels at ChatGPT. It's just going to be hard for it to get there because you have to feed it the keywords. It's kind of that thing where if you know what you're searching for and you use all the right words, it can give you a good answer, but half the time we don't even know what we're searching for. So it's a great summarizer, but just think about it as that. And I love using it on the command line like this. So hopefully you guys had fun with me, and we'll see you next time.